Alright, so today we're doing directional derivatives. I'm actually ahead of directional derivatives in multivariable calculus, but I haven't done multivariable calc in a while, so I'm just going back to this because I think this is really interesting. And they're pretty easy, kind of like a refresher on the whole multivariable calc thing. I mean, it's just one part of it, but it's really interesting. So I thought I'd do this lesson again. So we're just going to finish these problems. Should be easy. Okay. So we just have to find the gradient of this. This is literally just the directional derivative. It is the definition of the directional derivative. I think we just have to normalize the velocity vector of this thing. So, what is that? Normalizing the velocity vector is going to be the hardest thing to do here. Tangent of three halves. I'm going to just whip out a calculator in front of me. What is the tangent of 3 halves of 3 halves? Wait, I'm just going to search it up because it's giving a weird answer. Tan of 3 halves. Wait a minute. Oh wait, no, is it arctangent? Arctangent of 3 halves. Bro, I'm not getting an exact answer. Oh my god. Okay. How are we gonna normalize it? We could just plug this in, but I don't want to do that because that's a lot of just work. I guess we have to do that. Yeah, that's fine. So it's gonna take 2 inputs. What are the 2 inputs? Nope. Yeah, no, we're gonna arctangent of 3 halves. See, this should be it. This should be. What are the news? What is these news? Let's look at this thing. Bro, just give me the answer. Okay, it's this thing. It's this right here. That's how much it's how much goes up. It's how much it goes up. And then we just find the sine, the cosine of this. Is this in radians or? In radians. Oh my god, I have to go to another calculator. Okay, it's that in radians. That bubble. Oh my god. Why? Bro. What is this? Okay. Okay. So if we add those two vectors, then okay, we're gonna just try and plug it in. I'm gonna write on this thing. Ooh, fancy. No, it's so bad. F of what is x here? X has to be -1, right? Plus h times 2. -1 plus h times 2h. Oh my god. And then the y, what is y? Y is -4 plus 3h. Oh, okay. You can understand it, right? Yeah. Alright. Yes. So now what we do is we just, we just like put it in there. You feel? Okay. So it's just -4 plus 3h plus x, which is that, plus 1, which means this thing, times 2h. Okay. We're understanding it now. Yes. So it's -6h plus, -8h. That would have been bad. Plus 6h squared. Alright, so that's this thing. And then we just have to find out what the minus of this thing would be. So, so this thing, f of a, it would just be that and that. Right, yes. So it would just be 0. Because, that 0. Because it's multiplying by 0. Yes. Okay, and then you divide by h, and then this thing cancels out, but this thing doesn't cancel out that much. So when it goes to 0, this becomes 0. You understand? But this is left behind, so it's -8. If this is wrong, that's gonna be so sad. Oh, baby. Okay. We're understanding it now. Let f of x equal tan of y squared minus 3xy. Find the directional derivative of that. I don't even know what the derivative of tangent of x is. Oh no, that's a lie. I do. It's secant squared. So it's so just chain rule. But if we're taking it in x, it's supposed to, this is just, okay, so the gradient would be -3y for the x, and then for the y it would be secant y squared times 2y minus 3x. Right? Yes. Minus 3x, yes. And then we just multiply this by, okay, no, it's we multiply this by 1, 0. Just find the dot product of that. But wait, we first have to find the actual derivatives. So the first derivative is just going to be 0. Wait, hold up. Hold. Dot product is a time ax times bx time plus ay times by. The ax here is 0, so it's 0 there. And then the by is 0, so it's just 0 comma 0, making it 0. Oh, okay, if this is right, that'd be cool. That'd be nice. We get to skip some work. No! Bruh. It becomes a regular partial derivative. Okay. Oh, I should have seen that. All right, we can still clutch up though. It's only one mistake. Okay, this is a complicated one. We're going back to the drawing thing because I don't think you guys can see what I'm doing on the paper. Okay. So we just F. Okay. Now what is A? It's 1 plus 1 minus H. Comma -1 plus 2H and then comma, oh, this is gonna be interesting, comma 1 plus 2H. All right. Handwriting's so bad. All right. This thing, what is that? That's just 1 plus H squared. Right? Now we're just gonna FOIL it out. Minus H, because I forgot. Oh, we're getting speed. We're getting efficiency. We're getting speed. So that's 1. And then this is minus H. This is minus H. Oh, that would have been bad. Minus 2H plus H. And that's an N. That's an H. All right. First one. All right. When I walk right through Cupid meets me through and shoots an arrow through my heart. All right. Second one, it's minus 6y, so it'd be just 6 times the negative 6 times this, which would be plus 6 and then minus 12. Yes. No, 12H. Yes. Plus 2 plus 4H. Yes. And then oh shoot, I gotta do this thing. I don't really have to do this thing because it doesn't involve H. So when you divide by H, you're basically just ignoring it, you know? So all that's going to be left is -2. It's all the things that just have h, minus 12, and then plus 4. So that's going to be 10, -10. Please, -10. -10. Yes! Okay. We're locked. Alright. Don't normalize the vector for your calculation. Thank you. Alright, so this is literally just the dot product of the gradient and the vector. But it says not to normalize the vector, so we're not going to do it. It makes life simpler. But it's the wrong number. But it's fine. It's not the real number because it's not normalized. But it's fine. They just know that we know. You know? Okay. Okay, so we're gonna so for x, it's y squared cosine of x plus z. Right. Yes. And then for this one, it's sine of x times 2y times 2y. Oh, I should probably be writing it here so you guys can see my thinking, you know? Alright, so y squared cosine. Okay, we're going fast. We're also going down. But it's fine. You understand that, right? Y squared times cosine of x plus z. You understood that? Okay, so that's x. That's the derivative when you're looking at. That's the partial derivative for x. And then for the partial derivative for y, it's sine of x times 2y, because we just treat the sine of x here as a constant. Wow. And then it's just nothing here because it doesn't involve y. Okay, it's gonna get a little messy here. And then for z, this is constant, so it's just gonna be x. Alrighty, right there. So now we just plug in these values. So y, it's 2, so 4 times cosine of x. Cosine is 0, that's 1, plus z. What's z? It's 1 plus 1, comma, sine of x. That's 0 again. No. Yeah, that's 0. 0 times anything, that's 0. Especially 2y. And then x, it's just 0, man. So this one, it's 5, 0, 0, and then you just dot product this with the velocity vector. Oh my god, speed. 5, 0, 0. So it becomes 5. 5 or -5? 5. Just 5. Please. I need this. Please. Yes! Let's go. Okay. How much time have I been recording for? It's okay. Last one. Alright. Don't normalize, bro. It's so much easier if I just normalize it here, because square root of 2. Okay, we're writing it on here. Okay, I keep going to my notebook, but I remember that you guys can't see that. Okay, so x here is just 2y squared. That's it. Y here, it's just 2. It's just 4, actually. 4x y. Interesting. Now, why is that? Oh, get it? Because why? I'm sorry, guys. Alright. So now you just plug that in. That's 1. That's 2. 4 times 3. That's 12. Minus 1. That's negative 12. Wow. Crazy. And then you just multiply it. Negative 4 plus 24. What? Are we kidding right now? Are you kidding me? It's 20? Wow, that's crazy. Please be right. Yes! Okay. Alright, let's go. We're done. We got the full thing. We got the full thing. Yippee. Alright. That's it. Hopefully I can make daily videos. Yeah, see,